Supplemental math videos from Circle Christian School.
Rationalizing radicals. Rad radicals, the Cadillac of worms, the best there ever were. Don't be an irrational offender. They could never do. Be a rad radical, the Cadillac of worms. Rationalizing a radical happens when we have a radical down in the denominator. You can't have a radical down in the denominator because it's one, irrational, and the denominator is always the even pieces that a pizza has been cut into. So you can't evenly cut something irrational appropriately. So I'm going to just show you the first example, just a basic fraction with the radical down below, and how we're going to rationalize it. Rationalizing means we're going to make it real. So I'm just going to multiply it, the radical, by itself, because anytime you multiply a radical by itself, what's inside comes out. And if you multiply the bottom, you must multiply the top. So we get the square root of 3 over 3, because the square root of 3 times the square root of 3 is the square root of 9, which is 3. And now we have a real number. Let's do something that's a little more trickier. Sometimes you'll see the radical around a whole fraction here, and I don't mean a whole fraction, just a fraction. And there's a couple of things that you have to do to these. If it is a fraction that's already simplified, then you're just going to separate it, which will give you the square root of 1 over the square root of 3, and you're going to do what we did in the previous slide there. And the result will be the same, 3 over the square root of, my bad, the square root of 3. Get my whiteout. I love whiteout. It's one of my favorite friends. I am a heavy writer, and so generally I like using pen, and the whiteout is what helps me. We can have a more substantial fraction. For instance, maybe we have something like 3x to the third power over 12, maybe x to the second power. And when you get this kind of case, then what you want to do is see if you can't simplify before you start taking things apart. So again, you're going to go the number to number, letter to letter. And the 3 will go into the 12 4 times. And you have 2 x's down here, which is going to take away 2 from that one, and gives you a x up top and a 4 down below. So now what we have is the square root of x over the square root of 4, which actually ends up being kind of pretty, because the square root of 4 is one of those rad radicals. Let's try something even a little bit larger. For instance, maybe we have something like 27. Oh, let's try x to the 4th over 72. Maybe x. And again, you want to try to do as much as you can inside. And I know that both of these can be divided by 9, so this is going to give us a 3 here, and that's going to give us an 8 here. And 1x will take away from the 4 and give us a 3 here. And so now our result is, and we can start splitting things up a little bit earlier, is going to give us 3x to the 3rd over the square root of 8. Again, there's a couple of ways to go and do this. If you'll remember that the square root of 8 is always 2 to the square root of 2. And we can take an x out here, and it leaves 1 inside. The more that you simplify along the way, the less you have to simplify in the end. So now I'm just going to multiply this by the radical, square root of 2, and the square root of 2. And the result will be x square root 6 times the x over 2 times 2, because that's what that is, and 4. So that's just another one, rationalizing along the bottom here. What you're trying to do is simplify some things and then make it rational by multiplying it by itself. Now, every once in a while, we'll get a radical fraction that is somewhat of a binomial here over another radical binomial. And what we have to do here is that conjugate thing, which means we're going to rationalize by using the difference of two squares. So I'm going to multiply, and anytime I've got binomials, I like to put parentheses around them. It just reminds me that the two parts aren't separate, that it's one number altogether. So I'm going to do a multiplication here by the difference of two squares. You do down below, you must do up above. And we're going to have to do a little bit of foiling out here. The bottom part's easy because it's the difference of two squares. This is actually going to be the square of the first number, so we get a 4. A square of the radical, which we know is always just what's inside there, and then a minus sign in between. So we know we have a -1 here. And now we're just going to do the little FOIL thing. And we get a 2 and a minus square root 5. And then we have plus a 2 square root 3. And then the square root 3 times square root 5 gives us a square root 15. And our final result would be maybe a negative. You can throw the negative out front there, it just looks a little prettier. And there's nothing inside here to combine as a like term. Remember, when you add and subtract radicals, they have to be totally alike underneath the radical there, plus the square root 15. Square root of 15 is simplified as much as possible over the 1, which may also be shown as distributing this all the way out. A -2 plus the square root of 5 minus a 2 square root 3 minus a square root 15. You can't get more radical than that. So go out, be a radical, change somebody's day, share Jesus. Okay, I added this on after I looked at the last slide here, and you can add this for an extra 10 stars if you like into your notes. And I may have misspoken just a little bit here, that in that very first part when I said, hey, now you have a real number, well, technically it is a real number with an irrational component, because we have a real number down in the denominator, but we have an irrational component up above. So to be the real true math geek that I know I can be, it is a real number with an irrational component. There you go. Now go have a nice day.